Hi guys, we're starting chapter 4. Happy Geometry Day, by the way. And so you know how it goes at the beginning of a chapter, we got to take care of some basic information. So I know a lot of this stuff right at the start of section 4.1 is total review. So let's whip through this and make it quick and painless. Does everybody know what an acute triangle is? Hopefully you do, right? So you've got a spot for a description and a diagram. So description is 3 acute angles. Everybody knows acute means less than 90 degrees. Draw yourself an acute triangle in that diagram box. If you want to put angle measures in there, you certainly can. Actually, we'll talk about that in a section or two. Equiangular, so all 3 are less than 90. Equiangular. Notice the word angle in that equiangular. Equiangular means that all the angles are equal. We are not looking at the sides. So it's 3 congruent acute angles. If all of them are going to be congruent, they all have to be acute. An obtuse triangle, I know you know this because we talked about obtuse angles in general. One obtuse angle. There's actually some postulates and theorems that talk about the other 2, but one obtuse angle, and a right triangle has 1 right angle. Well, you're getting down your descriptions and diagrams. First of all, we need to make sure that, or I need to make sure that I mention this very important part on the top of that table. If I ask you to classify by angle, you're going to tell me 1 or 2 of these 4 things. Classifying by angles, not by sides. So I only looked at the angles. Are they acute? Are they obtuse? Are they right? Are they congruent? So only looking by angles. All right, hit pause if we need to. So now classification of triangles by sides. So now I'm not so interested in the angles. I want to know about the side length. Hopefully you know what an equilateral is. It's got the root word with the, or prefix with an equa, and then lateral means 3 congruent sides. Notice in that diagram, all 3 are marked with the congruent dashes. Really important that you mark those so we know they're congruent. Isosceles triangle, at least 2 congruent sides. Be very, very careful with that at least. We're going to talk in a minute where you might get hung up. At least 2 congruent sides. So it could be 2, it could be 3. Notice 1 set of sides are marked as congruent. They're double dashed in this case. We know that that means that they're congruent to each other. And a scalene triangle means that there are no congruent sides. Those are our only 3 options for classifying by side length. So equilateral, isosceles, or scalene. I know you've heard about these. But did you differentiate between we're only looking at angles and giving it a name, and then we're only looking at sides and giving it a name? So kind of an important, excuse me, distinction. So let's talk about parts of a triangle. We've actually talked about this when we did Pythag a while ago. We talked about parts of a right triangle. Notice I made this triangle right, or you could make your triangle right. So we need to make sure that we've got everything that we need in there. So first of all, the vertex or the vertices are points at which sides intersect. So how many vertices are on a triangle? 3 vertices. There's 3 sides that intersect. Hypotenuse is in a right triangle. And let's say it's opposite the right angle. We know that it's the longest side of a right triangle. We know that it's C when it comes to the Pythagorean theorem. A squared plus B squared equals C squared. We know all that kind of stuff. But hypotenuse is strictly used in a right triangle. Legs, we actually apply this to right and to isosceles. So in a right triangle, the legs are the 2 sides that form the right angle. They're A and B in our Pythagorean theorem. Legs when we're talking about an isosceles. I abbreviate this ISOS triangle, ISOS. It's shorter than writing isosceles. In an isosceles triangle, the legs are the two congruent sides. That's going to be important when we run into a couple word problems. It'll say something about the legs of an isosceles triangle. One of them is 2x plus 5. One of them is 4x minus 17. Find x. Well, if it says they're the legs, we know that those are the two congruent sides. Vertex angle is typically in a isosceles. Couldn't think of that word. Isosceles triangle. It's formed by the legs. They'll also mention that. And base angles, I should put an S on there, base angles in an isosceles are formed by a leg and base. So look at that triangle that I've got there. Make it right if it isn't. Let's call it ABC. I'm going to make A over here on the lower right, B up here, and C at the right angle. So first of all, that triangle, if I'm classifying by angles, it's a right triangle, correct? It's got one right angle. Also, what if I do this and I put congruent dashes on side BC and side AC? Well, now not only is it a right triangle, but it's isosceles because it's got at least two congruent sides. So I would call that a right and an isosceles triangle if I'm labeling by sides and by angles separately. So in this particular case, in this right isosceles triangle, the vertex would be C. The legs would be BC and side AC. The hypotenuse would be side AB. The base angles would be angles A and B. That's a lot of information, and we can go back to this. I'll make sure that we mention this again tomorrow, just labeling those things. But there's a lot of things happening on that triangle. There are three vertices, A, B, and C. What else? I think that's everything. The vertex angle would be angle C because it's formed by the two legs. Legs are the two congruent sides. So that kind of terminology, whether you've used it or not before, we need to make sure because that's how I write things and how I write problems, and that's how we form algebra problems. All right, let's do a quick practice number 1. This is a good one, and this is just knowing the definitions. I should have written this, instead of true and false, I should have written this as a sometimes, always, or never. The word all kind of makes it just always or never, basically. All isosceles triangles are equilateral. Is that true or false? Every single isosceles triangle that I get is equilateral. Are you thinking to yourself false? Because I could draw a picture, right? Is this isosceles? Not the best triangle. Is that isosceles triangle equilateral? It's got two sides congruent, so it says at least two sides, but that third side is not congruent, so it's not equilateral. But look at 1b, it says all equilateral triangles are isosceles. Well, here's an equilateral triangle. Is that isosceles? This is that picky little point in the definition of isosceles where it says at least two congruent sides. Are there at least two congruent sides on that equilateral triangle that I drew? That's true, right? The at least in the definition for isosceles leaves a little fuzzy area, so you just have to be careful. So it could be two congruent sides or all three. All right, let's go to let's go to this problem right here. Example or practice number 2. Classify the triangles acute, equiangular, obtuse, or right. So notice those are all angles. Classify by angles. So I don't know anything about the sides, but I do know what kind of triangle this is. What kind of triangle is this one with that 130-degree angle right there? It's got to be obtuse. Easy peasy, pumpkin squeezy. Let's skip this guy and let's talk about the next one. This is a good one. Classifying triangles by sides. So remember, look at what we're looking at when it comes to sides. Our side options are equilateral, isosceles, or scalene. So make sure you look at that and be able to differentiate between what are my angle options, what are my side options. It says point y is the midpoint of Vx. Wy is equal to 3.0 units. That's not labeled. I'm going to put that on there. Y is right in the middle, right? Classify triangle VWY. So this triangle right here as equilateral, isosceles, or scalene. Explain your reasoning. Well, we know that side VY is 3.0 units because we drew it on there. We know that VW is 4.5 units. In order to compare sides, we need to know VY. Do you know the length of side VY? Here's your key word. Remember, I like to throw those things in there. If it's midpoint and the side VX is 8.4, what does VY have to be? 4.2 units. Therefore, triangle VWY has no congruent sides. So what kind of triangle does that make that? Definitely a scalene. Notice we have no angle information. We don't quite know if it's equiangular or if it's isosceles or, no, not isosceles. If it's acute, obtuse, we might be able to make a guess, but we don't really know, so we can't say anything about angles. All right, let's do a quick setup problem because these are the ones that I like the most. Make you think a little bit, make you use some terminology, and we get to solve an algebra problem in the end. So it says find the measures of the sides of the isosceles triangle, KLM, with the base KL. So look back. The base in an isosceles triangle, actually, we didn't even define base, did we? The base angles are formed by a leg and a base. The base is actually KL, which means that's the oddball in this isosceles. Isosceles has two congruent sides, which means that KM and LM are congruent. If you can figure that out, you've got yourself your setup for your equation. KM and LM are congruent. It's because the base is KL. So base KL is not congruent. Once we've got that worked out, that D plus 6 on the diagram is really not helping us because it's not equal to anything else. So if we know that KM is congruent to LM, I've made that geometric statement, which we would probably do in a proof or something if we had one. Now we can substitute our values. So KM is 4D minus 13. LM is 12 minus D. We can solve that equation pretty easily. Take a minute, I'll take a minute, and then let's compare answers when we get that finished. Does everybody like a D equals 5? Did we answer the question? What does it tell us to find? Find the measures of the sides. So I need to know the measure of side KL, the measure of side KM, and the measure of side LM. So I've got a teeny bit more work to do in order to finish the sides. So if D equals 5, if I put that into KL, would you agree that KL must be 11? If I put that into KM, I'd have 4 times 5 is 20 minus 13 is 7. If I put that into LM, 12 minus 5 is 7. Does it make sense that KM and LM ended up both being 7s? Right? Those are the legs of that isosceles triangle. They have to be the same measure. That's what we said right back here in our geometric statement. They have to be the same thing. So we definitely should get a pair of equal sides. All right, last one. I want to talk about this example. I very kindly graphed this for you. In the assignment today, it's going to give you the points RST, and I'm going to ask you to graph them first and then classify the triangle by its sides. So your options for sides are scalene, isosceles, my brain's not working, or equilateral. What do we have to do in order to compare the lengths of the sides? So the triangle is RST, so I would probably need to know the length of side RS. How do I find the length of side RS on a graph? If you read the directions, you probably noticed already that you need to use the distance formula to find the length of the sides. Do you remember the distance formula? I'm hoping the answer is yes. Giant square root. Write this down if you need it. Put it at the top of your paper. Subtract the x's and square them. Subtract the y's and square them. Add it together after squaring. I don't even actually usually take the square root at the very end of it. I just compare numbers. So let's do a quick example and make sure that we've got this. So if I'm doing RS, if I've got them on a graph, you could write your ordered pairs and use those. If you've got them on your paper, whoops, don't want to do that. If you've got them on your paper, you could just concentrate on R and S. You don't care anything about that T ordered pair. So if I'm going to find the distance of RS, so I'm going to subtract the x's. So 4 minus negative 1, subtract the y's, 4 minus negative 3. And you might skip some steps. I know maybe I'm doing too much work for you, but I got a 4 plus 1, so 5 squared, 7 squared. So that's going to be 25 plus 49. So I should be looking at a square root of, gosh, I can't do that math, square root of 74 for the length of RS. Now, I could go down to a decimal and say that's whatever, 8 point something, or I could just leave it as a square root of 74, because when I do side RT, and when I do side ST, I'm going to compare those to see. I can't use slope to do this. Sometimes people try to use slope. You have to do the distance formula. So make sure that you go back in your old notes if you need to find distance formula. I believe that was way back in like chapter 1, a bazillion years ago. So I'm going to ask you to do 2 problems like this, so please graph them. I've got graph paper for you. And please show your length of your sides by doing the distance formula. Remember, if it's a horizontal or vertical, count it on the graph. Don't do extra work unless you love distance formula. If it is slanted in any way, you have to use distance. You cannot use slope. Your end answer, remember, is going to be scalene, isosceles, or equilateral, because you're going to compare the lengths of those 3 sides of the triangle. So I've got one more practice that you don't have, but we'll skip that one. And your assignments on page 241 and 242, 16 to 36 evens, 44, 46, and 50. These 2 guys right here are the ones that you need graph paper for. There's graph paper for you that you can use and staple right on. And I know I'm not here to do test corrections, so I'll give those back to you tomorrow. Those won't be due back until next Friday, which is the last day of the marking period. So shoot for next Wednesday for anything late, missing, anything like that. Everything else will be due as usual. Have a great day. I will see you guys tomorrow and get some serious work done.